the first 6 months of the year 1968. To many observers, a very quiet period at the National Aeronautics and Space Administration's Manned Spacecraft Center. Yet behind these walls and windows, there were, during the first 6 months of 1968, some of the most significant accomplishments to date for the forthcoming manned flights in Apollo. In the development and qualification of the spacecraft, there was a sense that many major obstacles had been overcome, that we could at last see manned Apollo missions on the horizon. The backbone of spacecraft development and qualification is ground testing. The command module, which will be both home and office for astronauts during the trip from the Earth to lunar orbit and return. The service module, which will contain a rocket engine and many spacecraft systems, and the lunar module, which will ferry astronauts to a landing on the moon, have all undergone years of ground testing by thousands of people. It was in space simulation chambers at the Manned Spacecraft Center that ground testing of the command, service, and lunar modules reached a culmination. For every module, at last complete with every system operational, was tested under conditions approximating those of an actual manned mission as closely as possible. In the tests for the command and service modules, which were called 2TV1, 3 astronauts lived and worked in the crew compartment continuously for 8 days and nights, virtually the same as if they were in space. For the lunar module, which was dubbed LTA-8, 2 crew members entered the crew compartment for 10 to 12-hour tests on 4 separate occasions. Working with the crew members, literally hundreds of people watched over the spacecraft modules during the tests, wringing out system after system. The conditions imposed by the chambers essentially matched those of a low orbit above the Earth, a near vacuum, a temperature range of hundreds of degrees Fahrenheit. When all was said and done, the Apollo spacecraft had proven its mettle, passing one of its final and most severe trials on Earth. But these were not the only tests. There were tests under a variety of conditions of the landing gear, which must absorb the shock of the lunar module's touchdown on the surface of the moon. There was the final and near-complete round of tests for the parachutes, which must lower a returning command module and astronauts to Earth. There were tests of the balloon-like devices which must right a command module should it somehow become inverted on the water at touchdown. In test after test, Apollo equipment met the standards required for manned space flight. But problems, which plague any program of magnitude, were still present. None was more trying than the one holding up final qualification of the lunar module's ascent stage engine. For months, engineers have experienced difficulty in getting the engine to burn with consistent stability, one of the most troublesome types of problems in the development of rocket propulsion. The problem was traced to the injector, which feeds propellant to the combustion chamber. The situation led to the development of an alternate or backup injector, and it is this injector that will be used in the first manned lunar module flight. Meanwhile, engineers will continue work with both injectors to assure that one is ready to meet the requirements for manned flight to the moon. While the final development problems were being ironed out of Apollo spacecraft systems, a final series of tests in a space simulation chamber was in progress for the pressure suit and associated equipment designed for extravehicular work during manned Apollo Saturn V missions. For the tests, a counterbalance was used to suspend all but 1/6 of the weight of man and equipment, thus simulating the effect of the moon's gravitation. Ground testing, which is so important to the development of Apollo equipment, has been conducted with such thoroughness that the unmanned flight tests are primarily aimed at confirming in space the results acquired previously on the ground. In early 1968, every Apollo spacecraft module was flown unmanned in 2 missions launched from Kennedy Space Center facilities in Florida. In the first flight, launched by a Saturn 1B, the lunar module LEM-1 was to perform so successfully that the remaining work to qualify the vehicle for man could be completed on the ground rather than in space as originally planned. In the next flight, launched by a Saturn V, the command and service module's performances equaled that of the lunar module. Generally, the 3-stage Saturn V launch vehicle too performed well, although an excessive longitudinal or up and down vibration was experienced early in the flight, and engine problems were encountered with the 2nd and 3rd stages. The problem of immediate concern at the Manned Spacecraft Center was the excessive longitudinal vibration, an effect known as the pogo phenomenon. A similar problem was encountered and overcome during the Gemini program. As part of the investigation in Apollo, Manned Spacecraft Center engineers assembled a ground test vehicle comprising all 3 modules of the spacecraft and the uppermost sections of the launch vehicle. And at the end of June 1968, they were preparing to subject Apollo to a series of vibration tests. The vibrations to be induced would essentially duplicate those experienced in flight. Meanwhile, solutions for the launch vehicle engine problems had been found by the Marshall Space Flight Center, and proposed methods for solving the vibration problems looked promising. Consequently, it was decided the Apollo program should proceed toward the manned phase of flights. Confidence was bolstered by the fact that both the quality and quantity of spacecraft produced by contractors were increasing rapidly. At both North American Rockwell and Grumman aircraft, spacecraft modules were being assembled. Systems were being installed. Hardware was being checked out. Equipment was undergoing final inspection and preparation for delivery to the launch site. While spacecraft were being readied for flight, astronauts were preparing to man them, working with a considerable variety of simulators and equipment. The astronauts are not unaccustomed to spending many hours in simulators for each hour they spend in space. Neither are they strangers to work of a more vigorous type. This was parachute survival training at Perrin Air Force Base, Texas. A precaution taken to make certain the astronauts were fully prepared in the event of an emergency ejection from an aircraft. The value of such training was never to be more clearly demonstrated than in the failure of a training vehicle used for simulating lunar landings on Earth. The vehicle had flown successfully more than 200 times, but during a routine training mission in May 1968, it suddenly went out of control. The pilot, astronaut Neil Armstrong, was forced to eject, and he parachuted to safety. The vehicle was destroyed, and at the end of June, the matter was still under investigation. In addition to the general astronaut training, flight crews intensified their preparations specifically for the first manned Apollo missions. This included not only detailed rehearsals, but flight hardware checkouts as well.
All right, we'll use the GNM.
Meanwhile, the first spacecraft, which will be launched by a Saturn 1B and manned by astronauts Schirra, Cunningham, and Isley, was delivered to the Kennedy Space Center. Technically, it was the most nearly flawless manned space vehicle ever received at the center. Pre-flight checkouts were started without delay. At the same time, spacecraft and launch vehicle equipment for the first manned Apollo Saturn V missions was being delivered to the Kennedy Space Center. This included the first lunar module scheduled for manned flight. With equipment and flight crews almost ready for launch into space, support teams rehearsed their roles in mission control at the Manned Spacecraft Center, at ground stations around the world. Concurrent with the approach of manned flight to the moon, the Lunar Receiving Laboratory at the Manned Spacecraft Center neared full operational status. Among the most recent equipment installed was a radiation counter, which is located in a heavily shielded facility 50 feet underground to help prevent interference from natural outside radiation. It is here that scientists will measure radioactive characteristics of samples from the moon's surface. There will, of course, be many other investigations and tests. One of them may involve these creatures: shrimp, grown in a carefully regulated environment at a Department of Interior laboratory near Galveston, Texas. Shrimp are one of a number of controlled organisms which may be exposed to lunar samples to make certain the materials present no danger to life. This is illustrative of the diversity of details involved in preparations for a manned journey to the moon. Throughout Apollo, the details leading to manned flight were being put into place at the end of June 1968. Preparations were well underway for the first manned Apollo Saturn 1B mission and the first manned Apollo Saturn V mission. The phase of the program that will culminate in the Apollo manned flight to the moon was about to begin.